you're struggling with memorizing half-angle formulas, or you hate how trig gameplay has just become memorization, then you need to understand this proof. As it turns out, double and half-angle formulas are tied together. You can't understand one without the other. By having a good grasp of the double-angle formulas, I can assure you that trig will be much easier, and hopefully you'll find yourself knowing the formulas off the top of your head. So to start, we first must go over the sum and difference formulas for cosine, sine, and tangent. So sine of alpha plus beta is going to be equal to sine alpha cosine beta plus sine beta cosine alpha. And actually, I'll do cosine in a different color. Cosine of alpha plus beta is going to be equal to cosine alpha cosine beta minus sine alpha sine beta. And finally, for tangent, tangent of alpha plus beta is going to be equal to tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Now, if you don't understand how each of these formulas was derived, then I highly suggest you check out my previous videos. So with that, let's continue on. So what if we had it where we were just adding the same angle? Let's say sine theta plus theta. Well, that would just be the same as sine 2 theta, right? I'll actually write an equal sign here, sine 2 theta. So what would that be equal to? Well, we can just plug in theta for every single alpha, for every single, alpha, beta, beta, and alpha. So what we're going to get is sine theta cosine theta plus sine theta cosine theta. And notice how they're just multiples of each other. So we can just rewrite this as 2 sine theta cosine theta. Sorry, I meant to say that they are just basically the same. So we can just write them as 2 times sine theta cosine theta. And for cosine, if we have the same angle, sine, or sorry, not sine, cosine. Cosine 2 theta. Now this is just the same as cosine theta plus theta. So we can replace all these alphas and betas with thetas, and then we're just gonna get cosine theta sine theta minus sine theta. Sorry, I'm getting these formulas mixed up too. Cosine theta minus sine theta sine theta. And this is just going to be equal to, well, do you see how this is just cosine theta times itself? So that's just going to be cosine squared theta, and sine theta is also multiplying by itself. It's also multiplying itself. So that's just going to be equal to sine squared theta. So cosine alpha or theta plus theta, or cosine 2 theta, is going to be equal to cosine squared theta minus sine squared theta. And tangent I'm going to write it over here. Tangent, if we have, we have tangent to theta, or tangent of theta plus theta, you're going to get that. You're going to get tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. Now, if you'll notice, these are actually, well, they're just multiples of each other. So tangent theta plus tangent of theta is just going to be equal to 2 tangent theta, because multiplication is just repeated addition. And over here, where tangent theta is multiplying itself, well, that's just going to be tan squared theta. So these are basically all the basic forms of the double angle formulas. And I want to go a bit more in depth on cosine, because cosine is a bit interesting. So if you recall, sine squared theta plus cosine squared theta equals to 1. And if you're not quite sure how we got here, I also made a video on this, and I recommend you checking it out. But we can just rearrange this to get that cosine squared theta. It's going to equal to 1 minus sine squared theta. So we can actually just replace what we got over here into cosine squared theta. So we can also, so this would just mean that, and sorry, this is not a fraction, by the way. And this would just mean that cosine 2 theta is going to be equal to cosine squared theta minus sine squared theta. And since cosine squared theta is also equal to 1 minus sine squared theta, we're just going to get 1 minus 2 sine squared theta. Because you're subtracting sine squared theta twice. And you can also do this the other way around as well. So we also know that sine squared theta is going to be equal to 1 minus cosine squared theta. And we just got this by rearranging this equation. So we can also just write cosine 2 theta as cosine squared theta minus parentheses 1 minus cosine squared theta. And if we simplify all this, well, you're going to get a minus 1 and then a plus cosine squared theta, because you're subtracting a negative term. So it's the same as adding that term. So this is just going to be equal to 2 cosine squared theta minus 1. So those are the alternate forms of the double angle formulas for cosine, and you'll find them to be very useful later. Now that is pretty much all there is for the double angle formulas. If this video has given you value, or if you'd like this concise, no BS way of teaching, then please consider supporting the channel. Otherwise, thank you for your attention, and good luck with your studies.